Okay, so our goal today is to find the length and midpoint of segments. And we have another postulate. It's almost kind of, well, postulate, the way we defined it was obviously true, and I don't have to prove it or convince you of it. So the ruler postulate, it's kind of one of those, it's obviously true. And it's that a number line is similar to or equal to a ruler. And what it means by that is that each number has a location. And since each number has a location, you can calculate the distance in between two numbers. Okay. Now, recap on the difference between AB, and the new one, AB. This first one that has the arrows going both directions, this is a line that continues forever in both directions. The middle one is a segment, and it has two endpoints. And then the one thing that people typically forget, that it does have an infinite number of points between them. Because a lot of people want to say a segment is a line with 2 points. And it's not. It has 2 endpoints, but there's actually an infinite number of points on that segment. They are just all the points or locations between the 2 endpoints. Okay. So what is this new thing here that we have not yet seen? A lot of people have tried using this to name other things, but they've actually are naming something completely different. So if it doesn't have anything over top of it, this is actually representing the length, okay, of segment AB. Or you can think about it as the distance between A and B. So this is the new one that we're going to talk about today. Measuring segments. So when we don't put anything over top, you're actually referring to the distance between A and B, or the length of AB. So our first problem today is going to be to find AB, or I guess we're going to talk first about how to actually find AB. So how are we going to find it? There is a formula to calculate the distance between A and B, or the length of segment AB. That's going to be equal to, does anyone remember what these bars are called? What is it? Do we remember? Those straight up and down absolute value bars. Those are absolute value bars. So we're going to take the absolute value of the difference of A and B. Okay? But I use little a and little b because little a is equal to the location of point A, and the small b is going to represent the location of point B. So when you are finding the absolute value of a difference, all we're going to do is we are going to find the difference. Of the locations, then make it positive. So that's how we are going to do it. Now we're going to actually practice. Now, many of your questions aren't just going to say find AB or find BC or find DC, but they might instead ask, is AB, segment AB congruent to segment CD? Now that's a new symbol, so let me zoom in on that. A congruent symbol is an equal sign with a squiggle over top of it. We will use that symbol all year. It might look a little foreign right now, but trust me, after a couple weeks, you're going to be so used to a congruent sign, it'll be silly. Okay. And we'll actually write that off to the side. But this symbol means congruent. Now we use that symbol when we're talking about figures. Okay, figures are congruent, meaning it is a very similar word to equal. That's why the symbol looks very similar to equal, other than that little symbol or that little squiggle over top. If figures are congruent, that means that they are exactly the same size or equal. Okay? But numbers are equal. That's the difference. So we say that numbers are equal, but figures, when we're talking about geometric figures, those are congruent. In order for figures to be congruent, okay, or if segments are congruent, then that means that they must have the same length. Okay, so that's just some new vocab terms and what we use them for. So that means if we're asked a question like this one over here, is segment AB congruent to segment CD? We'll have to find the length of segment AB and find the length of segment CD. And if those lengths are the same, then we can say that they are congruent. Are you with me? All right, so let's try this. Let me actually show you the diagram that was given with this problem. So this was the problem that was given. Here's a number line. And then we'll have some points on there. -2 is where point D is. -1 is where A is. 5 is where C is located. And 6 is where B is located. Okay, so this was the problem that was given. I'll write in a different color for how we go about solving this. So I'll use green. So if I was given this problem, I need to figure out what AB is, the length of AB, segment AB. So I'm going to figure out what is AB. And the way that I'm going to do that is by using this exact equation, the absolute value of A minus the location of A minus the location of B. And then I'm also going to have to figure out the length of segment CD, which this one I'm going to have to rearrange that equation because they didn't give me the equation for segment CD. So notice you'll just use small c minus small d, and you wrote the equation to find the length of segment CD. Are we okay with that? All right, so now we actually have to fill this in. So if I'm trying to find the length of this segment, where is the location of point A? In the diagram, where's that location at? -1. So I'm going to fill in -1 as A. Now, I would recommend using parentheses here because often people miss a negative symbol because it's subtraction. Where's the location of B? At 6. So I'm going to fill it in just like that. I'm going to solve this. What is the difference between -1 and 6? -1 and 6. It's what? -1 minus 6.
7.
Well, it's -7. Okay, we got to write it -7. Then, when we take the absolute value of that, now we'll have the distance, because all distances are positive, it will be +7. Okay, the absolute value says to simplify the inside and then make it positive. So when you're doing those absolute value bars to apply them, you just make it positive. Okay, then we're going to do the same thing with CD. The location of C is at 5 minus the location of D is at -2. When you subtract a negative, it turns into adding. So we have 5 plus 2 in there. So the absolute value of 7. And the absolute value of a positive number just stays positive. So this is just going to stay 7. Okay, so now that we did the hard work, that's the hard work, and we know that 7 equals 7. Okay, so that means that they have the same length. We found that AB is equal to CD. That's what we found, that those two lengths were equal. If those two lengths are equal, okay, we can conclude that segment AB is congruent to segment CD. So up here, if you wanted to answer it up here, we would say, yes. I just rewrote it down here. Because that was our final answer, was that those two segments were congruent. Okay. You can use the equation every time if you want. What I typically do is I sketch it out in my mind or I sketch it out on paper. Okay, and what I mean by that, I'm going to put it over here. If I had that E is at 74, F is at -5,000. Okay. You have two options here. Option 1, use the formula. Use the equation that we just worked with. Option 2 is to sketch it. Okay, so here I have a number line. I always put my 0 on there. And either both numbers are to the right of 0, both numbers are to the left of 0, or you have one on each side. So in this case, I'm not going to draw it to scale. I really don't care about that. I just care where they're located. So I have 74 over here, and -5,000 will be on that side of 0. And from there, I know that I have 5,000 in this area and 74 in this area, so I will be adding the numbers together. So from there, I can see with my eyes that EF would be 5,074. Okay. Now, if I was finding 2 over here, then I would find the difference between the two. Okay. But here I know that what would happen is when I would plug this in, I'd have negative 5,000 minus 74, which would become more negative, or I'd have 74 minus a negative. Either way, you're going to end up adding those numbers together. But I find that the sketch is much easier to kind of visualize. But I'm a visual person. If you like algebra, then you'd probably want to just stick with the formula and solve it every time. Okay? I don't care which option you choose. Whichever one is easier for you guys, I am good with. Okay. Are we good to flip this over? On the back side, midpoints. Think of average. Okay, so I'm going to draw a line segment up here. Here's D, this is B, this is 1, this is 6. If I am trying to find the average or the midpoint between 2 points, all you're going to do is, when you find an average, if I was trying to find the average of your guys' quiz scores, I would add up all your quiz scores, and there are 1, 2, 3, 4, 5, 6, 7 of you in here. So I would add them all up and divide by 7, right? Well, at this point, I only have 2 points, so I'm going to add them together, and I will divide by 2 since I only added up 2 numbers. So 1 plus 6 is 7 over 2. If I put that in a calculator, I get 3.5. So that means this middle, the midpoint, is at 3.5. MP being midpoint. Okay. So next we're going to actually define what a midpoint is. So a midpoint, here's another vocab word. So a midpoint of a segment, I'll put what we abbreviate it, we usually call it MP, so I put that there, of a segment is a point that divides the segment into 2 congruent, there's that congruent word again, segments. Which means that those 2 smaller segments have to have equal lengths. So this segment length and this segment length were congruent, or the lengths were equal, the segments are congruent. So the big thing to remember here is that when you are dealing with midpoints, you have that a part equals the other part. Part equals part. Okay? We also have a way to mark this on diagrams. If B is the midpoint, then we'll put these symbols. These are congruent marks. Okay? These are congruent marks. And we would say that B is the midpoint of AC, segment AC. Okay? Matching marks on a diagram means congruent segments. Okay. So from here, I could look at that and say that AB must be congruent to BC, segment BC. So let's do an example problem of where we might see something like this. Here's E, here's F, and here's G. They're marked the same, and I'm told that EF is equal to 2x plus 1, and I'm told that FG is equal to 3x minus 4. Okay. Since I can see that they have matching congruent marks, that means that those lengths have to be the same. Which, remember, my key thing I said was part equals part. That's what we have to remember. Okay? So if part equals part here, that means that segment EF must be congruent to segment FG because that's a midpoint, because part equals part. I could also just write that EF equals FG because that's talking about the lengths. Okay. Well, they gave me the lengths. They're written though as expressions, but I'm going to plug them in. So instead of writing EF, I'm going to write 2x plus 1. Instead of writing FG, I'm going to write 3x minus 4. Then I'm going to use my algebra skills to get x by itself. So I would subtract 2x from both sides. Add 4 on both sides. And I'll get that x is 5. Those algebra skills, those look familiar? Okay. So we get that x is 5. Cool. I like to write it so the variable's on the left. So x is 5. And maybe they asked me to solve for, maybe there was this thing over here and it said to find EF, to find FG, and to find EG. So it wants to know the lengths of all three of those segments. Well, EF was represented by 2x plus 1. So if we plug in 5, what's 2 times 5 plus 1? 11. 2 times 5 is 10, plus 1 is 11. Cool, that's 11. I can even mark it over here in my diagram. Okay, 3 times 5 is 15. 15 minus 4, I'm also finding is 11. Are these supposed to have the same length? Yeah, it's a midpoint. I marked them the congruent. They have to have the same length. Okay, so then what would the whole thing be if I went from E all the way to G? 22, you just add them up. And you just actually looked into what our next thing is, and that's the segment addition postulate, which again is one of those things that is just supposed to be obvious. But all this says is that if you take a part and you just did it, part, and you add another part to it, it has to equal the whole thing. So when we had 11 here and added 11 to it, it equals 22 because all you do is add them up. Okay, so I'm going to give you one example. I will show you the setup, but then we probably won't have time to actually solve it. This is D, this is S, this is T. This is labeled as 2x minus 8. This is labeled as 3x minus 12. And it tells us that dt is 60. And over here it asks us to solve for x. It asks us to solve for ds, and it asks us st, and it asks for dt. Now on this one, can we assume that these two segments are congruent? They look equal? In geometry, you're never allowed to assume, okay? So even though that S looks like it could be in the middle, we're never going to assume it unless it's marked with congruent marks. This one does not have congruent marks, so in your head you have to think one of them is going to be bigger than the other one. I don't know which one. It could be off by 1. It could be off by 100. I have no idea at this point in time, okay? But we cannot assume that S is in the middle because I don't have congruent marks and nowhere does it tell me that they are the same. However, I do see that from D all the way to T is marked as 60. So this whole segment here is marked as 60. So what I know is if I take 2x minus 8 and add 3x minus 12 to it, what will I get when I add up those two segments? 60. That's that part plus the part equals the whole thing. And that's what I'm going to go this route with because they gave me what that whole segment is supposed to be. And from here, you take the left side and you combine like terms. So 2x plus 3x is 5x. Negative 8 and negative 12 is minus 20 equals 60. And from there, you would solve for x. You would have x. You'd plug it back in here to find the length ds. You would plug it in here to find the length st. What would dt be? 60. It has to be 60 because they already told you. And I would double check that your ds and st add to 60 because they already told you the whole thing has to be 60. Okay? We're going to stop there, but you can go and figure that out if you'd like.